The best way to understand how .NET works is to briefly look at these layers. So here's a representation. It's an abstraction, a simplification. But this shows the different layers that you're going to be dealing with and need to have a broad understanding of. So this is a high-level view of the architecture of the .NET framework, with languages at the top, down through the runtime environment, into the .NET framework libraries, and down into the underlying Windows services. Binding the whole thing together is Visual Studio, which provides some great tools that you can use to build applications that take advantage of all of the features of this entire stack of technologies. So what I'm going to do now is talk a little bit and expand on three of the layers in the stack: the Common Language Runtime, or CLR, the .NET Framework base classes in the base class library, of which support for ASP.NET Web and Windows Forms applications are a part, and the .NET programming languages. Running on top of Windows and existing COM+ services, the Common Language Runtime acts as a runtime environment for all .NET applications. The principal purpose of the CLR is to load and execute code that's been compiled to Microsoft's Intermediate Language, or IL. Each of the .NET language compilers creates IL as its output, not machine language code, but IL. This behavior of compiling to an IL may be different than what you've used and experienced with other languages and development environments. Older languages generally compiled to machine language code that a computer processor could execute directly and was tied to a specific processor. IL is a level of abstraction up from that, a small level up from that, which is then processed at runtime for the processor that it's executing on. This is a fairly complex topic, but you don't need to worry about the details for now until you get into much more complex applications. The CLR also manages .NET base services, such as memory management, releasing resources, which is technically called garbage collection, and exception handling, as well as managing many of the tasks that go with running an application. The CLR lets a programmer run both managed code, which is code managed by the .NET CLR, and unmanaged code, that is, code that isn't managed by the .NET runtime. If you've created applications using Visual Basic 6, for example, you've written unmanaged code. This code has no knowledge of the .NET runtime and can't directly take advantage of its services. The same thing goes for applications written before the release of the .NET platform, including Windows itself, Microsoft Office, and more. Only applications written using the .NET platform can use the benefits of managed code, and developers convert more and more applications to managed code over time. So when you compile a .NET application, the compiler converts your source code to IL code. When you want to execute your IL compiled code, the CLR invokes a just-in-time or JIT compiler that compiles the IL code into native executable code designed for the specific runtime machine and operating system, and this graphic illustrates that. So any .NET language has a language compiler. It's compiled into Microsoft IL code, and then the JIT compiler, when you execute the application, executes and turns it into native code, which then the processor on the machine can execute natively. So unlike traditional compilers and linkers, .NET's just-in-time compiler can take advantage of the host processor, providing the best performance for the particular computer on which it's running. Because it doesn't actually compile the IL into native code until the application is running on the client computer, it can make appropriate decisions based on the target computer. So in essence, what it's doing is it's optimizing your code for the specific environment in which it's running, specifically the processor or processors on the machine where it's executing, whether it's a server running a web application, a desktop machine, or various other mobile devices. Now you might think that the JIT compilation would provide a huge overhead at runtime. This isn't so. Not only is the JIT compiler extremely fast, once the .NET runtime has compiled the native code on the target computer, it caches the result locally so that subsequent runs of the application pay no performance penalty at all. So you pay a very small penalty once and then not again, unless something changes. Now, in order for your applications to run on client machines, the current version of the .NET framework, or actually the version that your application is compiled against, including the Common Language Runtime, has to be installed on the client computer. It's likely that the .NET framework has already been installed on a Windows machine. It's just so prevalent now. But if it hasn't, you'll need to download this from Microsoft's site or include it with your application's deployment package. Although deploying .NET applications is beyond the scope of this course, it's a very important issue that you'll need to understand. All right, so the next thing I want to talk about is the .NET Framework Base Class Library. The .NET Framework includes a large set of functionality that makes your programming job easier, and it's called the Base Class Library, although you really don't hear that term used all that much. Pretty much people call it generically the .NET Framework, even though that includes a lot of other tools. So the Base Class Library, or BCL, which is also sometimes referred to as the Framework Class Library, or FCL, is a library of classes that are available to all languages that use the .NET Framework. The BCL contains a large number of classes, blocks of functionality containing properties, which is information or data about a feature that you can retrieve or set, and methods, which are procedures that you can call to perform some action. The library organizes these classes into logical groups called namespaces, such that each namespace contains a group of classes, each dealing with a particular area of the .NET Framework, each with a unique name. The BCL's namespaces provides classes that encapsulate a number of common functions, such as reading and writing files, drawing graphics, working with databases, working with XML, and so forth. And so here are a few of the most common namespaces from the base class library. There are many, many more. So the system namespace is the base namespace. It includes all of the other namespaces within the .NET framework. And it itself includes a lot of classes that are useful. So it has a lot of the essential support that you need for your programming. So a lot of the base types, including strings, integers, datetimes, booleans, and so forth, math functions, garbage collection, memory management, and more. Basically, it includes all of the stuff that pretty much every .NET application is going to need. Then there's system.data. If you're going to work with data, particularly going against relational databases, you'll use this namespace a lot. And there's various other sub-namespaces as well that have support for specific database technologies such as SQL Server. All right, so it provides classes for working with data, including SQL Server, OLEDB, and ODBC. And then there's system diagnostics. This provides classes that you need to diagnose your applications and has features like event logging, performance counters, tracing, and process management. All of that is built into the .NET framework, so you're able to instrument your code and get a lot of information about performance, both when you're building the application as well as when you've released it into the wild. You can get feedback about how it's performing. And then there's system globalization. If your application is going to be used by users of different languages, you'll need to get deep into this namespace. So it includes fundamental support for globalization. The .NET framework was built from the ground up to support globalization. System.io, another pretty fundamental namespace, includes fundamental stream support to target the Windows file system, including classes that can manipulate files and directories. So if you need to write out files, if you need to read the contents of a directory or folder in the file system, that's the namespace that you want to go to. And there's a number of classes that you can use. A lot with overlapping functionality, so you need to figure out how best to use them. But pretty much all of the features that you need in order to work with physical files. System.text, working with text as you would imagine. So you start to get a sense where Microsoft really spent a lot of time thinking about the names. The names really do identify what these things do. So system.text includes support for encodings in the string builder class and has then a child namespace called system.text.regularExpressions that has a very complete implementation of regular expressions so that you can parse text and match on patterns of strings. System.web is the fundamental part of the .NET framework that supports ASP.NET web applications. and it provides design time and runtime support for creating and displaying web applications. Now, System.web, with the release of ASP.NET 5, is kind of morphing a bit. But System.web is going to continue to support both web application or web form applications as well as MVC applications. And then ASP.NET 5 then introduced a whole new set of namespaces for you to use the new features. So just be aware of that little disconnect. And then if you're writing Windows applications, you'll use the System.Windows.Forms namespace a lot. This provides controls, designer, and runtime support for Windows-based applications. So if it's a sort of application where you install it on a local machine and it's used locally by a user at the keyboard there, then Windows Forms is the type of application you want to use. And then System.xml provides support for reading and writing XML content. Very, very rich support for XML content. This is largely because when .NET first came out, XML was the cool format. It was used everywhere. Microsoft used it for configuration files of a lot of its different technologies. And XML is still widely used. And so because the .NET framework itself used XML extensively, Microsoft has extensive support for it. Now, for web applications, JSON is becoming more the cool data format. It's a little bit more svelte than XML, not quite as wordy. So it's more compact, but throughout other kinds of applications and even web applications, you use XML a lot. All right, so again, those are a few of the many, many, many namespaces in the .NET framework. These are a few of the most common that you're going to encounter. But as you can see, the .NET framework uses a hierarchical system for managing the classes in namespaces. So as I mentioned, the system namespace contains more generalized classes than does the system.data namespace. The system.text namespace contains more generalized classes than does the system.text.regularExpressions namespace. Okay, so this filing system sort of organization makes it easier for you to find exactly the class that you need as you build applications. And don't worry about learning the entire .NET framework, particularly up front. Throughout this course, we're going to learn about a lot of different classes, a lot of different namespaces within the framework. So you don't have to worry about that. And those will serve you well for a lot of the applications that you write. But you'll also find that you'll start to get a feel for how the .NET framework is organized. And so it's going to make it much easier for you to find some new bit of functionality. So if you think, wow, I wonder if .NET framework supports cryptography, then you can kind of think through and look at the high level, and you can pretty much trace a path to get to the classes that you need. Okay, another note about all this is that Microsoft uses that top-level system namespace for classes in the .NET framework exclusively. For related .NET technologies that it produces, it generally uses Microsoft as the top-level namespace. Now, using Microsoft as the top-level name makes it clear that although the library is from Microsoft, it is not part of the core .NET framework libraries. Okay, so just keep that distinction in mind, because occasionally you'll see me using something like Microsoft.something.something. So that's not in the core .NET framework, but is related to .NET in some way. All right, then the third layer that I want to talk about is .NET languages. Microsoft provides several languages that can create managed applications, including Visual Basic, C#, C++, and F#. In addition, other vendors have created a number of different languages that can create applications targeting this platform, and that can use the .NET framework and its base class library. Each of these languages provides an implementation of the common language specification, so that each language can interoperate and take advantage of the .NET tools and functions. So how can various .NET languages interoperate? The .NET framework uses the Common Language Specification, or CLS, which creates an agreement between the different .NET languages. It includes the Common Type System, or CTS, and this provides a base set of types, so that all .NET languages can treat information in memory the same, independently of how the language itself works internally. No matter which .NET language you program in, the output is going to be Microsoft Intermediate Language, or MSIL or IL as I mentioned. Now, in theory, the same operation written in all the .NET languages should provide the same IL code. But this is rarely the case for non-trivial operations. The IL generated by each language compiler is under the control of different teams and people at Microsoft, and each team has different priorities for what to optimize and tune. This can account for some subtle and not so subtle performance differences between languages. But these are rarely of enough significance to worry about, and generally is not the basis to select one language over another. In the earlier days of .NET, C# had a little bit of performance enhancements, but those have pretty much gone away. There's really no difference between the different languages, for the most part. Okay, so let's start examining a .NET application. And the first thing I want to do is introduce the concept of an assembly. So when you compile managed code, you create a .NET assembly. Theoretically, an assembly can contain multiple files, although it generally consists of a single exe or DLL file. And the difference there just depends on the different kind of application that you're creating. An assembly is different from an unmanaged exe or DLL, of which you have literally thousands installed in your local machine. But these assemblies produced by .NET are different from those native code assemblies. The .NET assemblies contain not only the compiled program code, really the IL code, but also contains information about the assembly. This information, called metadata, provides useful information about the assembly for the .NET runtime and other managed applications. This information, generally referred to as the assembly's manifest, provides extra information that specifies details about the assembly. Specifically, you'll find a few pieces of information in the assembly's manifest. It'll include the version, name, culture, and security requirements for the assembly. It'll have a list of other files, if any, that belong to the assembly, along with a cryptographic hash of each file. It'll have a list of the public types defined in the assembly, and it'll have a list of external references that the assembly requires in order to run. So these are things that the Common Language Runtime, when you run your code, needs in order to load it into memory and execute it. So later on, I'll investigate the contents of an assembly using the .NET Framework tool ildasm.exe. Okay, so what kind of programs can you create? The .NET Framework provides classes and support for creating many different types of applications. And Visual Studio provides templates that make it easy to get started creating each of these types of applications. From Windows applications to websites, the .NET Framework and Visual Studio provide the tools you need. Okay, so Visual Studio provides a number of project templates that you can use. And these include templates for Windows applications. So this is for a standard Windows-based application, again, something that you install on a user's local machine. A console application. Use this template to create applications that run within the command window. And for most of the course, that's the kind of application that I'm going to be using because our focus here is on C# and not the different .NET application types. You can also create a class library. You'll want to use this template to create a library of functionality that you can package, deploy, and access from multiple applications. There's also a template for a Windows control library. You can use this template to create a library containing custom controls that you can host on Windows applications forms. And there's a corresponding web control library that you can use to create a library containing custom controls that you can host on web pages. And these are specifically for web forms types of applications, which is one of the ASP.NET application types. And then it has a very rich library to support ASP.NET websites. And these are dynamic websites where you produce the pages on the fly dynamically on the server and then deliver them down to the client. And then, of course, the client side, the pages, can also include dynamic functionality with things like client-side JavaScript.